Welcome to the first overview of the multi-stack MultiGeo Designer software. Thank you for taking the time to look at this new application. You begin by logging in to the system. You've created an account and you're ready to begin a new project. You're going to establish a series of simulation parameters, and the software will then determine the optimum system configuration. The first part of the process is to upload your design files. These are in a .gs or .greensleeves file format. These can be generated automatically using train trace, and we have other programs that can convert exported load files from other software. MultiGeo Designer also reviews the input to make sure it seems to be within a range. That's why you pick the type of building and a location, and then it looks at the actual loads and calculates the equivalent full load hours and compares it to ASHRAE data. And if it's significantly different, it'll give you a flag. Doesn't mean your input is wrong. It's just another way to do a sanity check on your data. So here we are. We're ready to select the load file that we have uploaded, and we've successfully loaded that file, and we're ready to begin setting up our simulations. Project information is where we're going to name the project, the client, the location, etc. Then we'll move on to the other parameters that we need to prepare an optimized design. And there's a lot of inputs here, but the good part is that we have defaults set up for most of them. And so there's really only a few that you have to change on a regular basis. It's important to make sure that you save your data on a regular basis. So here we're entering the project name, the building owner, location, the person using the software, the name of your company, any comments or description you'd like to add to help clarify what you're modeling. And remember to hit that save button. Then we move on to the next parameters that we need to input. Our next step here is to begin to prepare the inputs after we've saved our project information, and we have a note at the top that the information's been successfully updated. Now we're going to handle the inputs. So this is where we're actually going to name the project, and this is where the parameters for the simulation are stored. So the first with the load file. Now we're dealing with simulation parameters. And we've just saved that, and that is indicated on the top then that the project has been saved and it's been loaded. Now we can start our simulation parameters. Note that one of the first things that you set up on the simulation parameter is when to begin the simulation. For new construction, this would be when will the building's HVAC system be turned on. This is actually very important. Let's say you have a bore field that's designed to cover the heating load in the winter, but you start it up late summer and there's no time for that bore field to warm up. You might drive that bore field too cold during that first winter. So be as close as you can on what you think that start date might be. Here we've also set the simulation time, often 20 years. We set the time limit, determine whether a closed circuit cooling tower is isolated by a heat exchanger or piped directly into the bore field system. And remember to save your inputs. The sizing parameters page is where you establish your minimum maximum heat pump entering water temperatures. The Greensleeves Sizing solution is in essence the automatic sizing routine that's going to come up with an optimum configuration of bore field and closed circuit cooling tower. Parameters that are important include the building flow rate. Often what we'll do is simply look at the design loads and assume 3 GPM per ton for the maximum bore field flow rate, matching the building, 3 GPM per ton. And then a good place to start with the cooling tower is maybe nominally half or a little more than half of the building flow rate. The initial mean earth temperature is a function of the soil tests. Often it is close to the annual average dry bulb temperature. It may be a few degrees warmer, but if you don't know what your deep earth temperature is, that's a good place to go. We recommend simulating a cooling tower where it can run year-round, but limit the tower operation. And this gives you some room if the loads change. Now, this parameter we're changing right here is if this was an overheated bore field and this was a retrofit, this gives us the opportunity to turn on the cooling tower after some date in the future. So let's say that bore field's been running for 5 years, and then we were going to add a cooling tower. So we would simulate it with no tower for 5 years, and it would be overheated. And then at some date in year 5, we would allow the tower to come on. For the most part, you're going to leave these inputs as defaults. And I think one of the best heat pump efficiency models is this leaving water temperature from EER model. Don't forget again to save your inputs. Once you've completed those simulation inputs, we move on to the next parameter screen. Click on Setup, move to the GHX or the Geothermal Heat Exchanger design parameters. Typically, we'll keep a 400-foot depth of the bore, and we can input the number of bores here, the borehole diameter, and whether or not we have more than one loop in series. Typically, it's only one. When it does the math, what it's going to do is keep the number of boreholes as a constant, but then vary the depth. So if it needed more than 54 bores times 400 feet, it might increase that 400 to a different value. Here we're inputting the soil conductivity and soil diffusivity, again typically from a thermal conductivity test or an in situ formation test. The grout conductivity, often we see 0.88 thermal conductivity grout. The pipe diameter and the spacing of the pipe inside the borehole, the maximum fluid temps, and these are the temperatures from leaving the heat pumps going to the bore field. Once we've completed the bore field parameters input, we're ready to move on to the next section. And that will be where we define our closed circuit cooling tower or our dry cooler. And so here, again, we need to provide at least some beginning information. So the design flow rate, we'll typically use half of the peak load in tons and then 3 GPM per ton. Design airflow rate, you can look in our help function for a table, but often we'll go to a manufacturer's data, say Baltimore Air Coil or Evapco, and get a nominal airflow rate from their performance charts. Again, most of this data you'll leave as defaults. Later on, as you become a more sophisticated user, you might start tweaking this data, but for the most part, we've left these defaults at what are the most common values that we see applied as we're working through this. Additional parameters such as the cooling tower fan horsepower and the cooling tower spray pump horsepower are input. This is helpful for the energy calculations that we perform as part of the simulation and optimization process. As you wrap things up on this page, again, don't forget to hit the Save button, saving your parameters. Now let's move on to the next series of inputs. This has to do with the optimization design. Again, this is an area you probably won't get into, at least as an early user, but we want to have these parameters available as you become more sophisticated in your modeling prowess. We've used these parameters to help shape how the optimization process begins. We use a process called particle swarm optimization to rapidly converge to the optimum solution. Those top boxes are where you can change the parameters of the PSO, but again, typically not necessary in what you're doing. Part of the optimization process in design is looking at how to prepare a system configuration with the optimum bore field size and tower size to deliver, say, the lowest energy cost, lowest first cost, or lowest period cost. In the period, it's kind of a life cycle cost, but it's a study period that says the combination of energy cost and first costs reaching the lowest point. And so certainly you can drive to your lowest energy consumption or your lowest energy cost or the lowest study period cost. And that is often what our clients like to see is how we converge to that optimum financial situation. Now we're ready to begin our simulation process. So we've handled all the inputs that we need. Remember, we have defaults for virtually every input. And so we cycle back through life cycle cost setup if we're going to be using any type of a life cycle analysis. We're going to save our file, and we're going to prepare to complete our first series of simulations. So we're going back to the simulation parameters, saving the current project, saving the current job. Then we're going to select which type of simulation model we want, save it. It's going to overwrite the old file. We say yes, and we can then begin to execute the simulation. So you just click the simulate button at the bottom of the page, right there. It'll start spinning up the CPUs on the cloud and running the simulation. In this case, it ran very quickly, and we're able to then get the results. When the results button is available, you can just get a quick information on size of a cooling tower and how many bore feet. Otherwise, if you want more detail, you can download the results or even export the results in an Excel file format if you want to do additional post-processing on your analysis. So here's a sample 4-page report of this project that we ran. And you use the tools up in the upper left, as indicated here. First page being project information that you had input at the beginning of the process. Second page is looking at a Greensleeves or MultiGeo Designer solution on the right-hand side with the green tags versus a traditional ASHRAE hybrid cooling tower solution on the left. And so it compares your average, your min, and your max entering water temperatures to your heat pumps, your system efficiencies, your earth temperature. And so there's a great deal of information on this page that you can peel back and look at. Is the system providing the parameters that you want? And it does this also for the first year as well as the last year. So you get to see how the performance changes over time. The next page is if there is a boiler. If you needed a boiler on the bottom end, let's say you didn't want to do antifreeze, and in this case no boiler was needed, so there's no information here, but if there was a boiler required, it would indicate how much it would operate on the analysis based on the input loads, and it allows you to see those parameters as well. The final page is the closed circuit cooling tower analysis, comparing again the ASHRAE hybrid versus the MultiGeo Designer predictive control, estimating electrical use, heat rejection, water consumption, etc. So again, a wealth of information here that can be used to make your final decision on your system parameters. Once you're set with your design and you're ready to move back into the software, you simply hit the backspace key on your keyboard, and that will exit you out of that preview. And then you're back into MultiGeo Designer. At this point, you can look at some of the other things, tasks, history. History gives you all the simulations you've done, so you can access your projects and look at the results, or you can delete them if need be. We store them online for you. But that is all available there online. The help button has a lot of different information. The user's manual, some frequently asked questions, etc. This is very useful, and as we have more and more users, this continues to have better and richer content. So please give us input as you look at something that's not clear. Let us know, and then that's something that we can get into with the frequently asked questions and the user's manual to make sure that this is a bit of a complex piece of software, but it's really providing a great deal of analysis power in a relatively simple format, providing an opportunity to engineers they didn't have before. You can run multiple simulations simultaneously. So that's very easy to do. If you're working on multiple projects, you can set up different ones. That's what we're showing here. In this case, we're running different sizing methodology, and one's running the automatic sizing mode, and the other is just running a simulation mode. So you see they're both running in parallel. A nice feature here is you can have the software automatically notify you via email that your simulation is done. You just check that notify completion at the end there on the right hand side. And so we see both of these running in parallel right now. They're both completed, and you would then receive an automatic email if you had checked the box to notify you. Here's the simple summary of the bore footage and the cooling tower size and a boiler size. This one has no auxiliary boiler. So without having to download the results or do the preview report, you at least get some of those parameters up front, and you're all set. And that is a summary of how this software works. We're excited that you're considering using this as a design tool, and we will continue to add more and more features. Thank you.